There's an incredible amount of interest and investment going into encouraging conservation practices on farms. But how would we know what's working and what's not working without comprehensive, credible, and timely data?
Are we seeing conservation tillage, no-till, cover crop adoption? Are we seeing that trend up? Are we seeing the results of our, not only the nature conservancies, but our collective investments on the part of NRCS, on the part of companies, on the part of other partners? Are we seeing that manifest in the data?
Over the past 14 years, a collaboration of public and private sector groups have used remote sensing to create the Observational Tillage Information System, or OPTIS, to map these practice changes. And since that time, access to this data has become more critical than ever.
We don't want to be waiting until 2029 to find out what the Inflation Reduction Act did in terms of impacting changes in practices.
Today, we dive into these data, how it's all being collected and used, and what it takes to truly impact the future of agriculture at scale.
We felt it was very important to have these data out in the public to enable the public sector to track what's going on and to create more attention in terms of that this can be done with ag at scale.
Celebrating 14 years of the Observational Tillage Information System on today's Future of Agriculture podcast. Hello, fellow ag nerd. Thank you so much for joining me for another episode of the Future of Agriculture. My name is Tim Hamrich, and if you're interested in where innovative ideas meet practical realities in food and ag, I think you have come to the right show here. Today's episode is made possible thanks to the support of the Conservation Technology Information Center, or CTIC. Formed in 1982 to support the widespread use of economically and environmentally beneficial agricultural systems, CTIC's mission is to champion, promote, and provide information on climate-smart technologies and sustainable agricultural systems that conserve and enhance soil, water, air, and wildlife resources and are productive and profitable. Members of this nonprofit organization include farmers, policymakers, regulators, academic researchers, agribusiness leaders, conservation group personnel, farm media, and others. It's supported by the U.S. Environmental Protection Agency, USDA Natural Resources Conservation Service, and other public entities. You can learn more about their work over at ctic.org. I'll leave a link in the show notes, of course, but thank you very much to the Conservation Technology Information Center for supporting agricultural innovation and the Future of Agriculture podcast. All right, now let's dive into today's episode. I'm really excited about this because while the content in today's show is right in our wheelhouse of the data-driven intersection between technology and sustainability, I don't think we've ever done an episode quite like this one because we're not featuring an individual or a company, but a collaboration here, a group of people who saw a problem in the lack of important information and came together to make it happen. To tell this story, I'm very pleased to have on the show three guests: Bill Salas, who's the Chief Strategy Officer at Regrow, Dave Gustafson, Project Director at the Conservation Technology Information Center, and Chris Johnson, Director of Agriculture at the Nature Conservancy. I'm going to let each of them introduce themselves in just a moment here, but just for some brief context here. CTIC, Regrow, and the Nature Conservancy are all partners in bringing together the Observational Tillage Information System, or OPTIS. You may notice there's going to be some acronyms on today's program, so that's why I want to set this context. OPTIS is an automated system to map tillage, residue cover, winter cover, and soil health practices using remote sensing data across the United States. And before anyone tweets me concerned about using remote sensing to track on-farm practices, you should know while OPTIS calculations are performed at the farm field scale using publicly available data, the privacy of individual producers is fully protected by reporting only spatially aggregated results at regional and watershed scales. This collaboration, though, has been happening for over 14 years now, long before anyone was really talking about carbon sequestration or climate-smart agriculture. So in a lot of ways, the effort was ahead of its time. And it's a good thing it was because these data are needed now more than ever, with things like the Inflation Reduction Act coming out and numerous private companies and NGOs investing in efforts for on-farm conservation practices. So I highly recommend you stick around throughout all today's episode as we talk about the past, present, and future of Optis. We'll highlight some of the use cases it enables and talk about the importance of efforts like this for the future of agriculture. And I think one note I'd like to make before we dive in is that this isn't just about answering the simple questions, are farmers doing X practice or not? The data can inform much more nuanced questions. Things like, why do farmers employ conservation practices in certain areas versus others? Does this correlate with investments made in those areas? What is the relationship between, say, crop insurance and conservation practices? Or the impact of cover crops and conservation tillage on nutrient runoff, or maybe prevent plant acres? Or how does historic tillage correlate with current land values or land appreciation? I think the number of possible questions for this are endless, and the more robust and reliable the data gets, the more accurately we'll be able to answer them. So I think this stuff is really cool and foundational to making an impact on where agriculture is headed. I'm going to let each of our three guests introduce themselves before we dive in, so you can attach a voice with the name, starting with Project Director at the Conservation Technology Information Center, Dave Gustafson.
Dave Gustafson. I serve as an independent scientist these days. I'm focused on using modeling to help food systems meet nutrition needs in more sustainable ways. My degrees are in chemical engineering, but I've been using various forms of computer modeling to study a host of environmental issues, starting with water quality, which is where I first heard about CTIC, but we'll get into that later.
CTIC, as I mentioned, stands for Conservation Technology Information Center, and they've been a source for conservation data like what Optis provides for a very, very long time. Also joining Dave and making his second appearance now on the show is Regro Ag's Bill Salas.
Pleasure to have this chat today. I'm Bill Salas, the Chief Strategy Officer and co-founder at Regro Ag. I'm based in New Hampshire. My background is initially in remote sensing science. I worked at NASA for a bit, got really interested in the role of Earth observation for looking at landscapes and sustainability over broad areas. Then was an academic at the University of New Hampshire for about a decade, where I got involved in how do we take insights from Earth observation to understand what's happening on the landscape with respect to sustainability, agricultural production, resilience, climate change, greenhouse gas emissions. So as the Chief Strategy Officer at Regro, I manage two main functions. One is we keep moving the science forward. How can we continue to build on new scientific developments that are occurring currently, as well as how we can bring the science and data and technologies to public-private partnerships? We feel very strongly that providing science and data to the public is critical for addressing these issues around, climate change and food security, and the role of conservation ag to help build a more resilient production system.
Regro Ag powers agriculture resilience for today's leading retailers, CPGs, processors, and farmers, and was named one of Time's most influential companies in 2023. Bill's first appearance on this show was on episode 248 back in March of 2021, and it's great to get him back on here. Last but certainly not least today is Chris Johnson of the Nature Conservancy.
I'm Chris Johnson, and I'm the Director of Agriculture for the Nature Conservancy in North America. And in that role, I and my team lead our work to try to advance regenerative agriculture, adoption of soil health and best management practices in both crop systems, row crop agriculture, and also in grazing land and livestock systems in grasslands and pastures.
Many of you listening are probably familiar with the Nature Conservancy, or you might hear them referred to as TNC today. They're a global environmental nonprofit that creates innovative on-the-ground solutions to some of the world's toughest challenges. They are known for their collaborative approach to conserve our natural resources. Really appreciate having Chris, Dave, and Bill all on the show today to talk about this collaboration on the Observational Tillage Information System, or OPTIS, and what it means for the future of agriculture.
Well, my story with the data set that we're talking about today actually goes back to 1985, believe it or not. When I first joined Monsanto here in St. Louis, that's when I first heard about CTIC as a source of information about where conservation tillage was being practiced around the country. And at that time, this was being collected through a public-private partnership with USDA and others. And CTIC was the source of that information at the county scale. This was before there was an internet and everything else. So I can remember having a phone number and calling somebody in West Lafayette and then getting in the mail on a piece of paper. We didn't even have floppy disks or anything at this time. The information about where in the country conservation tillage was being practiced. So you fast forward then to 2004, and that's about the time that I joined the CTIC board after having been a user of the information for so many years in my water quality research. I was part of the effort to try to find a replacement, and it was really at that time that we were approached by Bill Salas and one of his colleagues, Steve Hagan. I think the name of the company, you helped me out here, Bill, I think it was Applied Geosolutions at that point. Is that correct? Yeah, so that's when I first heard about the whole idea of using remote sensing to track this information. I also remember going back to Monsanto and telling folks that, hey, there's this guy up in New Hampshire who thinks he can do this. And everybody just kind of shook their head and said, nah, you can't do that. It's too hard. The soil changes color depending on moisture levels and all sorts of other reasons why it would be technically very difficult to do. But nevertheless, collaboration started between Bill and his colleagues, and CTIC helped provide some ground truthing data. And I know Bill, as he'll explain, I'm sure in a moment, had many other collaborators as well. But we had a watershed project in Illinois called Indian Creek, where we had farmers who were telling us whether or not they did various forms of conservation tillage. And then the other thing that was very new at the time was whether or not they had cover crops in the system. And so it was shortly thereafter that we did an Indiana pilot, and CTIC, really played a role in helping to cobble together the funding to get that work done and also make the connection with the state of Indiana on all the ground truthing data that they were continuing to collect using that old methodology. And then a Corn Belt-wide study was pursued, and we helped, along with TNC and others, to, again, pull together all the resources that would be needed to pull off this public-private partnership. So that's really where it started from the CTIC side, but I know both Chris and Bill have their own stories.
And Bill, let's turn to you on this then. So was this just not happening elsewhere? Were you guys kind of the first ones to say, hey, I think we could use this new technology in this application?
I think we had seen maybe a couple of research papers beginning to look at this issue in terms of, for one area going in using remote sensing to say, can we map tillage or crop residue dynamics to estimate tillage practices? But it was really one time, one footprint, one analysis. So it's sort of limited in terms of how do we do this at scale. So actually some of that early work was done by a colleague at Bayer now who we've collaborated with over the years. So the whole idea behind OPTIS, or the Operational Tillage Information System, is saying, okay, researchers have demonstrated that this is feasible. How do we do this at scale? Right? Because we really want to use remote sensing to expand this information, be it synoptically. We could also do more temporal revisit, understanding what's happening in the landscape. So we pulled together a couple of proposals, one to NASA, hence the acronym OPTIS. You have to do a NASA proposal. You have to have an acronym, Operational Tillage Information System. But then we really sort of took off with funding from USDA under their Small Businesses and Innovative Research programs. They funded the original prototype development of OPTIS through a phase 1 and phase 2 series of grants that included collecting primary data on the ground to evaluate these algorithms and to improve them. So that work started the mid 2000s. So we've been at this for 18 years or so now. And it's evolved over time. As Dave alluded to, it's not just tillage monitoring now. We're looking at more conservation practices more broadly. Crop rotations, implementation of cover crop, and tillage systems. So along the way, we've had numerous partnerships and collaborations. This partnership with CTIC and TNC is sort of central to all of that. It's been the most long-running partnership, but we've worked closely with NRCS on some funding to support the Ecosystem Service Market Consortium to use the data to understand where do we stand now in adoption of conservation agriculture. So I would say we've had it's been fortunate to collaborate with both public and private sector partners to continue to evolve this platform to help support resilient and regenerative ag at scale.
Right. And I mean, this was before, I guess, the tidal wave of excitement over regenerative agriculture, even started forming, it would seem. So this is maybe a dumb question, but I'm hoping it will yield a smart answer. Bill, who wanted this information? Why was it so important to have this information at that time?
Great question. So our working hypothesis at that time was really around water quality programs and markets, right? So how do you understand where the adoption of conservation ag is occurring, but also just to understand information on, soil health management. The reason conservation tillage started is because of issues around soil erosion, and hence the formation of NRCS and other initiatives. So we felt, these data would be really valuable for more broad understanding of agriculture across the landscape, initially focusing on water quality markets. But then as the carbon and regenerative ag markets came into focus, that was another application that was sort of center for providing these data sets to help those markets be more transparent and lower the transaction cost to collect data, because it's very expensive to go out and visit fields to collect all this information. So if we can do this synoptically with satellites, it's much more cost effective. Plus, they can provide detailed information on the landscape. We can go back in time. We can use the historic archive of satellite data to really understand at each field level what are the transitions that are occurring, crop rotation changes, adoption of different tillage and cover cropping. So we sort of started with the premise that if you can measure what's happening on the landscape, you can actually develop better management strategies to help agriculture in its conservation journey. And that remote sensing based products that are reasonably accurate, and I'll come back to that because these are all models, so they're not perfect, but that are reasonably accurate can really help inform strategies and evaluate strategies that are implemented on the ground. So it's both for maybe targeting programs, but also how do you evaluate the efficacy of a program? You go in and incentivize conservation practices for a period of time. If you can monitor that landscape afterwards, you can then evaluate, was your theory of change correct, or how can you adjust your theory of change to help incentivize expansion of conservation agriculture. So we felt pretty strongly about if we can do a good job measuring the landscape and monitoring it, then we'll enable programs at scale.
Very interesting. Yeah. And let's bring Chris in here. Chris, when did the Nature Conservancy kind of become a part of this collaboration here?
Yeah. Well, so I think our involvement probably goes back about 8 or 10 years or so. And just to give some context on that, I mentioned earlier a little bit of the evolution of the Nature Conservancy as an organization, and moving beyond just kind of protection into trying to work on working lands more broadly. And we have a similar evolution that happened kind of with our work in agriculture. So we've been working with farmers, with ranchers for decades. Actually, some of the early work that I often talk about, Dave, was also in Indiana on Indian Creek. And in those days, we would do projects. We'd go and engage the local community. We'd be trying to improve often water. We'd be trying to improve like a creek that maybe had endangered mussel population or something like that. And the only way to do that was to actually engage the community and work with the farmers and try to figure out how to support them and get them resources in installing conservation practices, changing tillage practices, changing, cover cropping practices, things like that. And so, in those days, working a project at a time, you knew what was happening. You knew where the work was happening. You saw the before and after with your own eyes out in the field. But as we started to think about, well, how do we actually get beyond just going, farm by farm, county by county, project by project, to try to create momentum more broadly for change in agriculture at a landscape scale? Well, all of a sudden now we need a different approach to tracking progress. We need to leverage some emerging technologies and tools to be able to see, are we making a difference? Is change happening? Are these practices being adopted? We need to be able to see that at much, much larger scales where we don't have those one-on-one relationships, and we can't just kind of, verify by going out to the field. And so, I think we became aware of Optus and that remote sensing approach kind of in the early days of the expansion of our work in agriculture to really start thinking about how can we build momentum for large scale sort of landscape systems change. And it was just a perfect fit because we really wanted to be able to have information that could say, are we seeing conservation tillage, no-till, cover crop adoption? Are we seeing that trend up in certain places? Are we seeing the results of our not only the nature conservancies, but our collective investments on the part of NRCS, on the part of companies, on the part of other partners? Are we seeing that manifest in the data? And so, we learned about applied geosolutions and Bill and Steve and this work early on. And really, I think, my predecessors, some of my colleagues rolled up their sleeves and started to sort of do what the Nature Conservancy does, which is to try to build partnerships to help, raise money to create public and private sources of aligned funding and investment and collaboration that can really scale. And so, working with Bill and his team and with Dave and CTIC, that's really kind of 8 or 10 years ago is when we sort of stepped in and tried to see what we could do to kind of help add some momentum to the flywheel.
Great. And Chris, I understand we're up to 4.0 when it comes to Optus. Could you talk about what the platform looks like today, how it's being used, and how it's changed and evolved over the years?
Well, of course, Bill can speak more, accurately to the technical details, but I think like any science, it's evolving and improving over time. And the analytical techniques, the algorithms, and also some of the rules and the assumptions based around classifying an image, a different field, putting that in one bin versus another bin. We're learning all the time about how to do that better and better and better. Because, as Bill said, this is a model and the world is incredibly complex. And a cover crop that is emerging in, southern Minnesota is going to look entirely different than one emerging in, Mississippi. And so you need to sort of understand, what's that crop species, what's the timing, what's the climate, what are the sort of, conditions, antecedent soil moisture conditions, whatever it may be, and try to understand how to classify. Is that an emergent cover crop? Is it a failing cover crop? Is it weed pressure? Like what are we actually looking at from the satellite? And so we're getting better and better and better at that. But really, I think the thing that stands out to me, at the Nature Conservancy is just the power of these data in helping us understand how we're doing overall in this sort of broad push that I think the public sector and the private sector is making to try to transform agriculture to a more, sort of regenerative system that's based on good management of soil health. How are we doing? Are we making progress? Are we making progress as quickly or not as quickly as we'd like to see? And also, do we know if in one area we're making faster progress, what are we doing differently? What might be sort of the key ingredients in one place versus another that enables a certain set of practices to be successfully adopted? And you just can't really effectively answer those questions unless you have good, consistent data over a large area every single year over a long, long period of time. And so having little snapshots or having one method in Indiana and a different one in North Dakota, that doesn't enable you to kind of do that longitudinal, large scale, ongoing kind of gut check. And then there's just a whole host of really, really important research questions that they're not just research questions. They're like, how do we do better? How do we do better and faster to work with farmers, to support farmers in adopting these practices? Because if it were easy and if it were a no-brainer, Bill and his team would be tracking 100% adoption, 80% adoption, 90% adoption, but it's not easy. There are like real fundamental challenges to changing management on the ground, farm by farm, and we're working through that, and these data are just really, really critical to kind of help overcome those challenges.
Yeah, maybe I'll follow up on that in the sense that sort of the new version or Optus 4.0 data set, the first versions were really, we cut our teeth on the Corn Belt, right? Large fields, corn, soy for the most part. We knew the phenology of the cropping seasons. We were able to sort of map those landscapes pretty straightforward. But we really wanted to do this across the continental US. And so you have very different production systems in different geographies. And so the model itself has to be flexible and has to reflect what's happening in terms of those agronomic practices and how conservation practices are reflected in those systems. So this new version is really the first extensive product across the US that includes a broad range of cropping systems. But then we also, in terms of large interest from research, we wanted to see how we can improve the estimate of uncertainty in our quantifications, right? It's a model, it'll give us a number. What does that number mean? So as you begin to consume the data to either evaluate policies or for research applications, you want to know the estimate of uncertainty. So we've continued to do extensive validating of the model and tracking its performance over time. In addition, we realized that to understand the impact of a conservation ag and the efficacy of conservation ag in different geographies, we want to do more than just like map cover crop or not. We want to try to map attributes of these systems. Agriculture are systems. Like, okay, as Chris alluded to, can we say, well, cover crop started to emerge, but it wasn't a successful stand establishment, maybe driven by weather that fall, right? And can we disentangle, the intention of cover cropping from actual successful cover cropping driven by regional differences? And the success of a cover crop has a big impact on water quality, right? How much nitrogen, how much sediment is it protecting by having a good establishment? If you have poor establishment, then the impact is less. So characterizing these practices beyond just individual practices, but into systems is really a focus of what we're doing now in terms of to evolve the utility of Optus products more broadly across both policy landscapes and ecosystem service market landscapes.
Well, I know the most accurate answer to this question is it's way more complicated than that, but I'm going to ask the question anyway. How accurate is it? How accurate is the model?
The answer is it depends. We have regional differences where we're looking at, I would say, what would be a typical remote sensing model application where we're having accuracies on the order of 75 to 90% accurate. Now, a key aspect of the new Optus 4.0 is we actually map crop type in season to reduce the latency of these products, because before we were relying on government data sets as an antecedent to monitor the landscape. But I'll say that tillage is actually probably the most difficult, because the way the platform works is it tracks residue fractions on the field post-harvest to bin residue fraction and characterize tillage practices based on residue fraction at planting. Right, so there are a lot of things that will affect the residue on the surface with or without tillage, weather events and other things. The preceding crop influences the residue characteristics. So that's the one that's most difficult in terms of taking a product that says, okay, this has 28% residue cover. Is that conservation till or is that conventional till, right? It depends both on your definition of those based on residue fractions, but also it's mapping a continuous variable to a discrete set of practices. I will also note that there are many tillage systems that have less impact on residue, surface residue, and those are difficult to pick up with an approach like Optus, like vertical till, right? Disturbs the soil, disturbs it less, but actually disturbs even less of the surface residue, so it's harder to pick up. So we're working through ways of trying to further characterize the landscape to sort of fill some of these weaknesses in the product at this point.
Yeah, and one of the complicating factors with all of that is the source of ground truthing data. So I think everyone would acknowledge, I think that, the presence or absence of cover crops is pretty easy to see. It's either there or it isn't. I mean, there's the issue around weeds and things like that, but most trained observers who go around with the survey method can accurately identify the presence of a cover crop. However, correctly identifying the various forms of no-till, conservation tillage, reduced tillage, conventional, those terms have kind of floated around actually in the years since CTIC has existed. CTIC way back when decided, somewhat arbitrarily, but it's kind of stuck, that 30% crop residue constituted conservation tillage. But the definition of what constitutes no-till has fluctuated a bit. I mean, in terms of its relationship to residue level, that is, because it does actually depend on what the previous crop is. And so there are a lot of challenges in tillage in terms of the accuracy question that just make it more difficult than the presence absence of cover crops. But accuracy continues to be a challenge, but it is absolutely the best thing that's available publicly right now. And we stand behind what we're doing here, but we also absolutely recognize that nothing's perfect and it's never going to be perfect. But I think there is room with more ground truthing data and applying better technology. The amount of remote sensing data is increasing all the time with new satellites going up. I think we're going to see ever increasing levels of accuracy with the kind of method that Regrow has developed with Optus. I don't know, Chris, I know you folks have looked at this in some detail in certain geographies. I'm sure you have a comment on this question too.
Well, sure. I mean, I would just say all of the sources of information about practice adoption have uncertainty and error associated with them, right? I mean, our USDA ag census, which is just a critical source of information. I mean, first of all, it only comes out every 4 years, and second of all, it's survey based, and so it requires self-reporting, and it's just a subset of the farmers, and so there's there are uncertainty bounds around that, and there's some certain assumptions that have to be made about, is everybody interpreting the questions the same way, is everybody answering them the same way, and similarly for the windshield surveys that Dave talked about earlier, they're subject to certain error. They're also obviously only looking at a part of the landscape. So the thing that's been really interesting for us is, as the Corn Belt data were coming out, as the Indiana pilot was done, the conversations that it spurred with our local staff in states and with our local partners about comparing across different data sets and really people's comfort level with different data sets or familiarity with different data sets. And, if a state survey says 1.5 million acres and Optus says 1 million acres, which is right? Well, neither of them. And so, but it spurred some really good conversations in lots of different places about the trends that people were seeing, what they were hearing when talking to farmers or talking to farm groups or others on the landscape. So, I agree with everything that Dave and Bill have said about the gradual kind of process of improving the science and improving the technology and the interpretation, and the fact that that this is science and this is a model, and so we're not going to attain perfection, but we need these data. We need to be able to look at a big picture of the landscape and try to understand how we're doing overall, and where do we need to work harder, where do we need to double down, what's working, what's lagging a little bit. So it's really, it's imperfect, and yet it's also really, really important for the work that we're doing.
And Chris, could you talk more about that, as far as if there's any examples you can give of how this data has helped to inform strategy at the Nature Conservancy?
Yeah, well, I was part of a study. I can probably give a few examples. I was part of a study with Professor Linda Prokopi at Purdue, a social scientist, and her lab, and there was a paper published as a result of this. But that study used county level Optus data to look at counties in pairs, and all else being equal, you would look at two counties and you'd say, well, they should have a similar cover crop adoption rate, similar climate, similar soils, no particular reason why you'd expect a higher rate in one versus the other. And yet, nonetheless, the Optus data would show a county had 10% and its companion county only had 2%. And so then what this research team did is they actually did focus groups in each of those counties to try to understand what are some of the underlying factors. Is the same amount of incentive money hitting the ground in both counties? Is the same amount of technical assistance available? What are the social networks like? What's the presence or absence of conservation champions like on the landscape? And so you can start to ask kind of social, institutional support questions related to why. And then if you uncover a gap or a barrier or a challenge, you can direct resources and investment to try to redress that. And long story short, what we learned in this study was it seemed to be kind of a constellation of factors. It wasn't just money. It wasn't just the presence of technical assistance, but it was actually the strength of the relationships and the interactions between the public and private actors on the landscape, between NRCS, between Extension, between the ag retail, between the commodity groups. Do they work well together? And are they kind of creating, this sort of positive feedback cycle that is helping deploy and support the advancement of, in this case, cover crop adoption on the landscape? And that kind of constellation of things seemed to be what emerged from there. And so, the data are super helpful for trying to give us insight on how to do better in delivering solutions. It doesn't mean it's going to be easy. It doesn't mean it's, you can just sort of find a silver bullet and solve the problem everywhere, but the data are really helpful for that. I'll give just another quick example. We worked with a master's student at Cornell who was working on an analysis of cover crop adoption and crop insurance and indemnity payouts, and sort of did a large scale kind of correlation of, what was the rate of insurance loss that was experienced at a county relative to the rate of cover crop adoption. And again, this was correlative, not causative. There wasn't, a sort of controlled experiment that was run. It was observational data kind of after the fact. But nonetheless, she saw this like clear signal between counties where there had been a higher rate of cover crop adoption. There was also a lower rate of crop insurance payout, due to loss. So, that of course begs more questions. Well, why? Well, what's going on? What's the mechanism? And how do we use that information to improve our delivery of solutions? But really, that's just scratching the surface a little bit. But these data are super, super helpful to kind of fine tune our delivery of solutions to farmers.
Absolutely. And I know Dave spoke earlier to kind of what gets him optimistic that the accuracy will continue to go up. And Bill, I was wondering if you could speak to that as well. What's being done today to continue to ground truth this? And what do you see as room for future improvement in the accuracy of the model?
Yeah, I think we're getting access to more and more ground truth data through partnerships on a project by project basis. And so we roll all that up together to have a better calibration and validation data set. I'll also say that, with the advancements in artificial intelligence and machine learning, there are new tools to be used to analyze satellite data to begin to understand subtle differences across the landscape. We think that's going to lead to continued improvements. Now, I will say, AI is a tool. I'm a little afraid of the black box nature of it, because when we first started Optis, we were looking at how optical sunlight interacts with the surface from a physical perspective, right? How do we separate out wet soils from dry soils from crop residue for physical scattering mechanisms? You use AI, you have to be careful about too much of a black box and really understanding the implications of those models. But I think it's a key tool if we use it properly. I also see that, and we touched on it earlier a little bit, sort of better characterization of the practices themselves. So for example, cover cropping, right? Okay, cover crop presence or absence, but its impact is really like how many days of green cover, how many days of living roots do you have in the soil? Not just cover crop was present, but actually the cover crop was interseeded. So you had a continuous living roots throughout the fall into the early winter until senescence. So those kinds of metrics, I think, will improve the characterizations of these practices at landscape scales and help me better manage and understand the impacts of adoption of conservation and understand what are agronomically sound and regionally specific practices that can help achieve the outcomes that are being sought.
And there's been quite a bit of public investment, at least relative to, historical initiatives through like Inflation Reduction Act comes to mind, but also Growing Climate Solutions Act, Climate Smart Commodity Partnerships efforts. It seems like Optis is in a good position to help kind of track the impact of those types of investments. Is that happening in a formal way currently?
I can speak to this a little bit because this was another interesting kind of use of Optis that I just wanted to share anyway. So you all have probably heard of the CEAP, the Conservation Effects Assessment Program that USDA supports to basically, try to study the ROI, the benefits of conservation practice investment. So the Nature Conservancy has been leading a USDA SEEP wildlife study for the Upper Mississippi River Basin, looking at the implementation of conservation practices on this agricultural landscape. How does that relate to sediment and nutrient loading in the Mississippi main stem, but also tributaries? And then how does that in turn affect aquatic biodiversity and fish communities? And part of that study, there's multiple models that are being developed. We're working with colleagues from Texas A&M and University of Kansas and Missouri and many other places. But part of that baselining will be using Optus data to feed into that model to estimate the current sort of best available assessment of what's on the ground right now. And Optus data will inform that modeling of that baseline. And then there are going to be explorations of scenarios for, well, what if we had more of this practice or more of that practice? What might that generate in terms of outcomes and benefits? And so that's, USDA funded analysis of the impact of conservation practices and federal investment in conservation programs and, on our waters and on our wildlife, on our aquatic biodiversity. And so that's one example of where the data are being used to kind of, estimate, are we getting what we pay for? Are we getting the benefits that we seek?
Great. Well, just kind of looking forward here, what's next for this project specifically? What's on the top of your mind as we enter 2025 and beyond for Optus? And Dave, I'll let you start with that one.
Sure. Well, we're actually just now wrapping up a major project with funding from Foundation for Food and Ag Research. There's also been contributions from the Walton Family Foundation to our efforts here at CTIC. And this is the nationwide application of the Optus methodology for the whole country for the years 2015 to 2021. I would just say parenthetically that also had some other deliverables around grasslands. We really haven't talked about grasslands today, but a subject for a different podcast. And also a livestock inventory that are now on the CTIC website. And we have been talking with Regrow and have been quite public about this, about the need to continue this data set coming. We think there's huge public benefit to seeing these data available now publicly for 22, 23, and beyond. Circulated a letter, had about 30 different organizations co-sign onto that. But we're going to continue pushing for this. Most recent thinking is that we might enlist the states, those that are part of the hypoxia task force, which will be coming together for a meeting here in early 2025. So we've just started conversations about maybe hosting a conversation ahead of that next task force meeting, trying to drive a little bit more support from the states and others to help keep this information flowing and get it out to the public as quickly as possible. One of the big advantages to this data set, we mentioned the issue of latency earlier. It takes a long time for the USDA Ag Census to report out. It was actually just earlier this year that we had the 22 Ag Census. We won't have the 27 Ag Census that come out every 5 years actually come out until early 2029. I don't know, Bill, are we still going to be doing this then? I'm not sure. But at least for me personally, I just turned 66. I think I'm still going to be involved because I love this work and I love working with these guys. The point is, we don't want to be waiting until 2029 to find out what the Inflation Reduction Act did in terms of impacting changes in practices. So we need to be having this information come on a regular basis. And I really do believe there's a very strong case to be made that this information needs to continue. And now that we've kind of passed out of the research phase, the current project was Foundation for Food and Ag Research. I think we've kind of moved from this being a research effort to being much more operational. And therefore, really the folks that should be supporting this broadly, I believe, ought to be public dollars coming through organizations like USDA. And I know that's a policy question and all that, but in all seriousness, it really does feel like from a public goods type of perspective that really is what makes most sense at this point. But it's going to take us making a case for it, and we plan to start making that case here in the new year.
The operational use goes back to the original acronym, the O in Optus, Operational Tillage Information System, which is all about how we can take these technologies. But Tim, to your question, I think what we'll be focusing on is the continued improvement in the quality of the products and the characterization of the landscape in terms of understanding conservation adoption at the landscape scale. So, internally we'll be investing significantly in improvements in the products, reducing the latency of the data for both the public and private sector use, as well as continuing to explore new partnerships on how the data can help address issues. So, for example, we've been doing some work on human health related to algal blooms. So, Dave, you talked about Western Lake Erie and the issue around the impact of harmful algal blooms on neurological diseases. So, working with NIH to begin to link satellite-based water quality modeling with landscape-level monitoring of agricultural landscapes and other landscapes that are all connected in the end, right? As we begin to look at these systems, we want to understand those interconnected aspects of land and water and human health and food security. So a lot of interesting research opportunities ahead of us to increase the use of these data, I think.
And Chris, anything you want to add on this topic as far as kind of where we need to focus from here? And specifically, I'll just for food for thought, talk about just the importance of MRV in general and continuing to invest in these types of platforms.
Yeah, well, I mean, I would zoom out just a minute and, kind of remind myself and all of us, like, the reason we're talking about this is because we have these really, really pressing climate challenges, biodiversity challenges, freshwater, contamination challenges in some places, like, Western Lake Erie was mentioned, and other places that have algal blooms. So this is not just an academic exercise. It's not just a research exercise. There are critical challenges facing our farmers, facing our ranchers, facing all of us that are looking to a future where we have clean water, access to sufficient water, and we still have the tremendous biodiversity that we all enjoy and sort of take for granted in our world. And so, I kind of bring it back to that. Agriculture and improving how we manage working lands has a huge role to play in solving those challenges. There's nearly 1 billion acres of agricultural land in the U.S. alone, and so they have a huge potential impact and benefit in terms of tackling climate change and providing solutions to these other problems. So, with that in mind, how do we scale up, increase the pace of adoption, of transitioning and transforming the way we manage our lands to get to kind of a new normal where we're managing soils in a way that can build resilience and reduce, nutrient loss and store carbon and all these sorts of things? There's a whole host of financial and technical and social and cultural and, technological barriers. And one of them is knowing if the changes that we're investing in, the projects that we're investing in, are actually getting us where we want to go. And knowing if our public dollars, whether it's federal dollars or state dollars, are actually generating a return on investment. And so data like Optis that can actually help us track our progress, help us learn over time, help us develop better solutions, more cost-effective, higher ROI interventions based on research, based on studying the efficacy of certain things. Data like Optis are key in sort of that process of learning. And, time is not our friend here. Like, these challenges are really urgent. And so we need access to annual data. We need access to consistent, comprehensive data. We can't only rely on survey data, that come out every 4 or 5 years after the fact. We need to be managing kind of real time. And so, I think systems like Optis are just a key tool in the toolbox to help us all get smarter, be more effective, do better with our limited resources, collaborate better across the public and private sphere. Because at the end of the day, we're trying to actually support farmers and ranchers to manage their lands in ways that that work for them and that generate all these other benefits and outcomes. And data is just a huge part of that. So I know I zoomed out a little bit there, Tim, but I just think it's really important to keep in mind this is not just an academic exercise. There's actually real stuff on the line here in terms of farmer and rancher livelihoods and in terms of kind of broader climate issues, environmental health and biodiversity and things like that.
Well, that is going to do it for today's episode. Thank you so very much to Dave Gustafson, Chris Johnson and Bill Salas all for being on the show. I think this stuff is really, really important work and a fascinating story. I appreciate those guys sharing so much historical context and real world examples of how these data are being used. If you'd like to learn more, this is publicly available. You could just go to the CTIC website, ctic.org, and find these Optus data and take a look for yourselves. So I'll leave a link for that in the show notes, and I really appreciate CTIC partnering with me on today's episode. Well, that's it for today. Thank you so much for listening. I do not take it lightly. I'll be back next week with another story of ag innovation.